All right. So yesterday, we were given a point, a coordinate. So you were always given the x and the y, and you had to solve for the r in order to give the trig ratio, right? So if you're given a coordinate, you plot it, get your x and y, solve for your r. They'll always ask for a trig ratio that needs an r, because they won't ask for tan or cotangent because you already have x and y, and you wouldn't have to solve for anything, right? So they give you a coordinate, they'll ask for sine or cosecant, or sine, I just did that, or secant or cos. I just really repeated the same thing twice. Good times. So when they give you tan theta equals 4/5, they're actually giving you either x or y or r every single one of these times when they tell you what quadrant they're in. So you need to draw them. So this one here says, and you know to do this because it will say tan theta equals something. It'll tell you what quadrant it is in, and then it will ask you for a trig ratio. So it'll ask you for cos theta or sine theta or secant theta. That's when you know to do these, okay? And they pop up all the time. So you're given like a ratio, you're given a quadrant it's in, and then you're going to be asked for like cosecant theta or cotan or something like that. So we have tan theta equals 4/5. It's in quadrant 1. This is the easiest way it could be given to you because it literally tells you it's in quadrant 1. So we go to quadrant 1 and we draw ourselves a triangle. The triangle always goes with the x-axis. If you drew every triangle correctly, you would actually make a bow tie. See, if you drew the one in quadrant 1, quadrant 2, quadrant 3, quadrant 4, if you drew them all correctly, they make a bow tie. Don't be drawing this. I don't even know how to do it. Don't do that. It's like a skirt and it's an hourglass. That's just stupid. That's what that is. Don't be stupid, okay? All right. I don't know why I just did the tap thing when I could just went and swiped, but the joy. Okay. So we know the quadrant it's in. Then we can label what tan is. Tan your Xbox or xyphon process. Good time. So tan your. So they gave us y and x. So actually, this is very similar to what we were given yesterday. Yesterday we were given a coordinate. Today we're given tan of this. But we're actually still just given x and y, are we not? Just to know another weird way. So we know x is 5. We know y is 4. We need to find r again. So r, oh, I don't like when the marker's like that. R squared equals 20, oops, I skipped a step, 5 squared plus 4 squared. R squared equals 25 plus 16. R squared equals, what do we get? 41. So R equals plus or minus square root 41. Which one's it going to be? Plus because it's the, and the radius always has to be, because it's a radius, which is a length, and lengths can't be negative. This is great. It's like fill in the blank, and you guys are really good at it. That's what this is. Okay. So we get square root 41. And we can't reduce square root 41. If we could reduce it, like say it was square root 24, we'd reduce it to 2 root 6. You have to reduce it, but 41 we can't. Now, we're supposed to list the remaining ratios. The box is really tiny. So for each one, we're going to pick 2 ratios to find. Of cotan is not one of them. Okay, I'm not doing cotan. Because cotan would just be 5/4. Okay? So, what if I give you sine theta? Sine your resume. So, it's y over r. So it's going to be 4/√41. And then what do we have to do? Rationalize the denominator. So it's 4√41 over 41. Then I want you to do secant. Secant goes with cos. It's the reciprocal trig function of cos. So it's the flipped version of cos. Cos is cook extra rice. So this is going to be rice extra. So rice, which is square root 41, and then x, which is 5. And this is great because it's already rationalized. Oh, you missed yesterday. Oh, it was a good day. It's recorded, so you can enjoy it too. All right. So then it gets a little bit harder for the drawing part, not for anything else. Everything else is the same, but now it gets a little bit harder for the drawing. Not substantially, but a little bit. So we have sine theta equals 3 over root 10. It's between 90 and 180. So what quadrant is that? 2. So we go and draw ourselves. And what do we label this? Sign your resume. So what are we looking for this time? X. So you guys know that Pythagorean theorem is x squared plus y squared equals r squared. So if I'm looking for x, I'm just going to do x squared equals r squared minus y squared, right? It's always r squared minus the other side. So I'm going to do x squared equals r squared, which is fantastic, because the squared cancels the square root, minus y squared, minus 3 squared. So x squared equals 10 minus 9, x squared equals 1, square root. We take the square root, we take the positive and negative. And this is why drawing it is extremely important. Drawing the triangle is extremely important because based on this triangle being drawn, what's my x have to be? -1. Because remember, we're technically plotting this point right here. And this point is at -1. We agree? So often they're going to ask you for a trig ratio that needs you to have x. Why would they do that? In case you get it wrong, make sure that you have to solve for it. If it doesn't need x, you could literally just take these values and flip it. So the only one they're not going to ask for is cosecant. Cosecant is just a flip of sine, right? So I'm going to make you do cos theta, and I'm going to make you do cotan theta. Try them out. Cos, we're going to cook extra rice, so -1 over root 10. Need to rationalize it. So I'm going to get -1 root 10 over 10. Oops. Do I need the -1, or can I just have a negative sign? Just have a negative. Cotan is the opposite of tan. Tan is tan your Xbox or xiphoid, you know. Tan, so it's y over x, so cotan is x over y. Okay. The last two examples are the ones where it takes you a little bit more thinking. So we know it says sine theta equals -2 over 3, right? Then it says tan is greater than 0. We have to find out which quadrant it is in based on where those two things fall. So we're going to pick what quadrant it is where sine is negative and tan is greater than 0. What does that mean? Tan is positive. Remember, whenever they say greater than 0 or less than 0, that's indirectly the whole year telling you it's positive or negative. That's just their fancy way of saying it. So we need to find out what quadrant has sine negative and tan positive. So remember, based on casserole, C-A-S-T. So where is tan positive? 3 and 1. Where is sine negative? 3. So we have to find out where they both are. So we have to find out where tan is positive in 3 and 1. Now, of 3 and 1, which one is sine negative? 3. So we pick that one. Does everyone understand that? I need the little boards. You're all giving me the same look again. Yeah, we have 2 nods. I will take that as 3 nods. We have the whole class getting it now. I have 3 nods. Oh, 4! Yay! I feel like I'm winning. I feel like I'm like an auctioneer. We have 3 now. 4. Give me 5. Okay. All right. So sign your resume. Now this is a key thing. They could have written it like this. And then I know that people start getting it more incorrect if they have it like this. So everyone's like, y, r. So y is positive 2 and r is negative 3. Can that be possible? No. What about that minus sign? What is the rule about the minus sign that's in front? It can be on the bottom in the denominator. You could move it to the very front of the whole entire fraction, or you can move it to the top, to the numerator. Doesn't matter. No, the only rule is you can't have more than one. If the negative is there, you can only have one. You can move it wherever the heck you want, but you can only have one. So this one was out in front. Well, we know that the only thing that can be negative in this case is actually y, right? Because r can't be negative, so we'd have to write it like this anyways. Plus, we drew it. We've drawn the actual diagram, so we know what's negative. So I know r is negative. I know y is negative 2, or r is positive. I know y is negative 2. I know x is going to have to be negative as well, because in quadrant 3, both x and y are negative when you look at a point in quadrant 3. And we're looking at this point, technically. So we're solving for x again. So x squared equals r squared, 3 squared, minus y squared, negative 2 squared. X squared equals 9 minus 4. X squared equals 5. Square root. When you take the square root, you take the positive and negative. So x equals plus or minus root 5. And in this case, minus. So I'm not going to ask you for cosecant, because cosecant would just be flipped of whatever the heck I gave you in the first place. So I'm going to ask you for, I want an x in the denominator, so you have to rationalize. So I want secant and tan. Remember, if you forget what the reciprocal functions are, they're on your formula sheet as well. So secant is the reciprocal function of cos. Cos is cook extra rice, so this is rice extra. So we're going to get 3 over root 5. I'm going to put the negative up here just because I prefer it up there. If you left it on the bottom, you're absolutely correct. Okay? I just put the negative from the square root 5. Multiplied by root 5. And you get negative 3 root 5 over 5. Or you could have 3 root 5 over negative 5. Still correct. Correct? And then tan your x box, so negative 2 over negative root 5. Why does this become positive? Because the negatives cancel. And what about this quadrant? What? Tan is positive. So if your answer is actually not positive, you messed up. Because it told you it is. Okay? Multiply by root 5. So 2 root 5 over 5. Make sense? You do 4. Okay. We need where cos is negative and where tan is negative. So cos is negative in quadrants 2 and 3, whereas tan is only negative out of those two quadrants in quadrant 2. Cook extra rice, so negative 5 and 13. So we're going to get y squared equals 13 squared, r squared, minus negative 5 squared. Y squared equals 169 minus 25. Y squared equals 144. Square root. So y equals positive or negative 12. And in this case, it has to be positive 12 because it's in quadrant 2. So do you see, if you don't draw the actual diagram, you will be guessing at the sign, which is a problem because they'll have the wrong answer there. Right? Cotan is x over y, so it's negative 5 over 12. Sign your resume 12 over 13. They want us to determine the exact value of these. As long as they fall in the unit circle, it's really easy. Okay? So you're going to want to take out your unit circle. And first off, check if these fall on the unit circle. Now, if they don't fall on the unit circle, you could find the coterminal angle and see if they fall in the unit circle, right? If the coterminal angle falls in the unit circle, would you still write the same answer? Yes. Now, the unit circle, remember, gives you the coordinates what and what? X and y, correct? Or cos and sine. We agree? Now, So some people say, but it doesn't give me r. You don't need r. If you have cos, secant is just the flip of x, right? So it'd be 1 over x, whatever x is. If you need cosecant, you take whatever sine is or y is and flip it. If you need tan, tan is y divided by x, so sine divided by cos, right? And cotan is x divided by y or cos divided by sine, and those are actually on your formula sheet. They're really nice. So if you need to find off the unit circle tan or cotan, the actual formulas are right here at the top. Cos divided by sine, sine divided by cos. Okay? So we need tan of pi over 2. So if we need tan of pi over 2, we need to go to pi over 2, and we need to divide y over x. So at pi over 2, or 90, what is my y? 1. And what is my x? So it's actually undefined, because you can't divide by 0. Because if you look here, y is 1, x is 0. Off your unit circle. Whenever it says what is the exact value, that's a huge hint you're pulling stuff off the edges of your unit circle. That's where all those exact values sit. Okay? Well, what's the exact value? Okay, now what's the exact value of cosecant 7 pi over 6? Is 7 pi over 6 on your unit circle? Okay. Cosecant is a reciprocal function of what? Sine. So if I find out whatever the heck sine is, and I flip it, because it's a reciprocal function, I'll have cosecant. So what is sine at 7 pi over 6? Pardon? Negative 1/2. So it's going to be negative 2 over 1, which is negative 2. Sine of negative 300. What is the actual coterminal angle of negative 300? Positive 60. Yeah. So let's go to 60, and we're going to take which value? Sine, which is y, which is root 3 over 2. Secant of 60. It's the reciprocal function of cos of 60. What is cos of 60? 1/2. So it's 2 over 1. Cos of 150. So go to 150 on your unit circle and take off the x value. What's the x value at 150? Negative root 3 over 2. So if you have your unit circle drawn already, these aren't too bad, right? Sine of, what is it? Yeah, so it's 1/2, isn't it? Negative 1/2. You guys are killing me. Just kidding, you're not. I'm still here. You can't get rid of me that easy. Yeah. Because it's a 30-degree reference angle. And all the 30-degree reference angles have cos of negative root 3 over 2. Okay, sine of 315 is the y. So it's root negative root 2 over 2 because it's in quadrant 4. Sine of negative 30. Negative 30 is coterminal with positive 330. So we go to 330, we pick the y value. What's the y value of 330? Tan of 240. Now is where the life gets a little bit more rough. Not terrible, but just a little bit more work. Tan is y divided by x, or sine divided by cos. It says it up there. So at 240, it's going to be y divided by x. And a lot of people want to write it like that. But we're dealing with fractions, right? So we're going to want to write it sideways. Y divided by x whenever you're dealing with a fraction. So what's y at 240? negative root 3 over 2. And then we're going to divide it by x. What's x? Negative a half. When we divide fractions, we multiply by the reciprocal. So negative root 3 over 2 times negative 2 over 1. These cancel, and we're left with positive root 3. So it's not ridiculously harder. It's just that you can't just go right there and pick it off. Okay? So tan of 480. 480 is not on our unit circle, but 120 is, and 120 is the coterminal angle to 480. So what's the y of 120? Root 3 over 2. And what's the x? So that's the same as root 3 over 2 times negative 2 over 1, which equals negative root 3. Now, in trig, they write the squared in the middle, and I've tried to think of why this is a good idea for them. I've come up with one reason over many years of trying to decide why this is a good reason. You can't type it in like that. In derivatives, you have to change it to do that for calculus. So why is it good? Well, I think it's because if the squared is at the back of the cos, so say it was like cos 225 squared, then you're just squaring the 225. You're not actually squaring the cos. So what does that mean? And how can you even punch that in your calculator? Because you can't go cos squared 225, because when you press the cos button, a bracket opens up instantly. So how do you insert a squared in there? You can't. So whenever you see something like this, this is the exact same as cos 225 degrees squared. I should put an equal sign, not an arrow. That's just silly. So that little squared in the middle just means cos 225, the whole thing squared. Okay? So if we find out what's the answer to cos 225, so what is x at 225? It's negative root 2 over 2. But now we have to square it. Square a negative becomes a positive. Square a square root, the square root sign goes away. Square a 2, you get a 4. So it's a half. Now the next ones are all in radians, and some people struggle with radians. Could you convert it to degrees and still find the same answer and be fine? Yeah, you're just finding that terminal arm on the unit circle. Now, some people say, well, then I have to convert my answer to degrees. No, your answer is the answer. Your answer is where it terminates on that arm, right? Those answers around the outside of your circle are neither in degrees nor radians. They're answers. They're where that point exists. It's the length of that point, right? The x and y value. So I want you guys to try that one. Don't do these. Just do these. Negative 2 pi over 3 is the same as what? Yeah. So it's cos, so it's negative a half. Sine of negative pi is 0, so 0. Cos of negative 5 pi over 3 is the same as 120. Negative 5 pi over 3. Oh, it's 300, so it'd be 60. So it is cos of 60, so it should be a half. And then tan of 2 pi over 3, what's y divided by x? Is it root 3 over 2 divided by negative a half? Okay, this is the last thing we're going to do today. It's just practicing how to punch them into your calculator. So remember, the moment you press sine, cos, or tan, or second sine, second cos, second tan, your mode has to be in radian or degrees, depending on what the heck it's in, right? So sine 1.92, what does it have to be in? Radians. So go put your calculator in radian mode. .9396. Then it's tan of negative 500. So we need to be in degree, yeah. Secant. If you're like, oh crud, I don't remember. Go to your formula sheet. Your formula sheet says secant theta is equal to 1 over cos theta. So secant 85.4 is equal to 1 over cos of 85.4 degrees. And then cotan of 3 is equal to 1 over tan of 3, and 3 is in radians. Okay? Now, guys, back here, I have, say I wanted to check if this is right. Tan of 2 pi over 3. 2 pi over 3 is in radians, correct? So if I went to my calculator, made sure it was in radians, I'd go tan 2 pi divided by 3, get my answer, and then do what with it? What do I get? 3. So you can always check these as well, right? You can check them. You could go tan of 7 pi over 6 in your calculator. You're going to get root 3 over 3. In your calculator, you're not going to get root 3 over 3. If you did tan of 7 pi over 6, tan 7 pi divided by 6, you're going to get 0.5773502.692. Exact value of that, I have no idea. But if you find your answer, so it's, we said it's root 3, bracket, root 3 divided by 3, it's the exact same answer. So I walk away from that question knowing I was right. Okay? So it can't get you the answer always, but it can at least make you walk away from that question going, got this. Okay?